when Eween asked me to talk about this, I was trying to think, what am I going to say? And as some of you know, the history of JWST leads us to have many conversations about what is the role of JWST, why do we do this? And I thought I'll just take some lessons from that and see if something clicks here and we get on to it. So I wanted to start with this word, humility. I think a lot of those of us who've lived through this program, we got used to this word quite a lot. And let me just start here. Here is the evolution of the total amount of money NASA, the US public, invested in the James Webb as a function of time. And you see the growth in the cost curves going up and up. I started the project in 2003, so that's where I'm going to start with my numbers. Those numbers I actually understood at the time. And every time you show a graph like this, everybody says, well, we always knew you didn't really know what the cost was, you guys. I will tell you that every step of the way, the people involved with the project believed sincerely that these were the right numbers until they weren't. And the paradigms kept shifting. There was this crisis in 2009, and then we managed to hold it for a while. And I'll come back to this second crisis, what cost us an additional $800 million at the end. And we finally got this launched. But if you're going to start projects like this, a certain amount of humility in what we understand and how complex these things is absolutely essential. And I think that was the first lesson from this project. If something is going to go wrong, it will, and it did. The second part of this is the scientific side of this. I'm not going to click. There we go. You saw this from Adam yesterday. I just thought it would be a useful way to think about it. We have our modern model of cosmology. You basically take the conditions from the early universe, you apply everything you know, you turn the handle, and you make predictions of how fast the universe is expanding today. And of course, in 2008, 2009, that was how dark energy came along and got the Nobel Prize. And as Adam said yesterday, what's happened so far is that JWST has actually reinforced this big yawning difference, as you see, between the red and the blue. The blue is today's universe measurements, the red is the predictions, and we now have a 5 sigma difference. And that's the magic number, 1 in 3.5 million, that this is just statistic. And when George Eustathio, who actually led a lot of the Planck, saw this JWST data, this is the statement he made to Adam. Okay, finger points at the standard model of cosmology as a problem. So we have a problem. We don't understand our modern cosmological model. And then we have science, the exoplanets. And we've spent a lot of time looking at this. We're looking at the habitable zones, this TRAPPIST system. And, I was listening today and I was putting crosses across all the ones that we don't think they are atmospheres. Doesn't mean they aren't rocky, but we don't know what's going on. And of course, we're integrating down deeper and deeper on E. And we heard from Nicole, at least, it's not a flat line, which is good to know, but it's still not a result. Now, I have many National Solar Observatories, part of AURA. I will tell you, my solar scientists think it's the height of stupidity or insanity to look for life around M stars. And they're very happy we're doing it. But because of, and they say, well, good luck, Matt, but let me know what you find. You may prove us wrong. It's going to be much harder than we think to actually find life around stars like this and to unequivocally check the presence of biosignatures. And I think a little humility is required here in how we think about whether or not we'll find life. And we've heard today and yesterday about we don't know how all those early metals formed so quick. That uncertainty, and I just plagiarized this from Joe Silk, who used this in a book of his. I think it's humility in the face of persistent great unknowns is perhaps JWST's greatest contribution so far. Now, that's not all. I think there's something else going on here. It takes a village, in JWST case, actually a small town, to build something like the James Webb. And all of you know that without large engineering teams, we wouldn't actually get to do what we do. And this is actually a quote that is up at CERN, in fact, and I stole it and put it against James Webb. Without our engineering colleagues, we wouldn't have a telescope. And it's been a hugely complex undertaking. Made sure I didn't get any ITAR material, any of this. And, you know, we have a vast engineering team that has to work coherently across continents. Massive amount of documentation, but there is an amazing commitment to make this machine work. And then there's this result, which we heard from Klaus. You know, what did it take to get these results? It took a team that created and curated the data. And I just thought some metrics would be very useful. I put them up here. Look how successful the ERO early release team that Klaus led, and there he is in the photograph, is compared to the statistics on the launch. This is the users, the page views, unique page views, as compared to what the launch was. Several orders of magnitude more interest from the science. And that took a multidisciplinary team, science writers, educators, graphic artists, data gurus, multimedia specialists, and of course, active researchers. It took a team. And now we look at how we're doing science today. We're flattening science. One of the commitments that Aura has always made is to make science a democratic undertaking. We spend a lot of time trying to work out how to lower barriers to entry to use telescopes as complicated as the Hubble Space Telescope and now the James Webb Space Telescope. If you look at that bar chart, it is the percentage of first-time PIs that use Hubble. And that big boost there is when we started the dual anonymous review process, i.e. people, we don't know who you are when you send in a science case. This is equivalent to doing the music interviews behind a curtain with a carpet. All you hear is the music. All you read is the science, and that has enabled a great burst in new PI users. And it hasn't diminished the publication rate, as you can see on the other curve. On JWST, of course, we don't have very many cycles, so we don't know how many new users, but it is noticeable that for the first time, 10% of all successful proposals are graduates. The other interesting thing, their teams, they're much bigger teams than we saw typically at Hubble. If you just do the integration, you know, it's 13 and gone up to 16. The equivalent today is still roughly 10, and that's a very skewed distribution. Teams are the new normal. I mean, just look at the team that Nicole is running, 30 people on her video. And we're making the data accessible. That yellow bar, those of you who are not used to seeing these publication charts, this is not cumulative, this is the actual publications every year. On Hubble, half the data comes from archived data only. Half of the publication. And that is growing rapidly in James Webb, as you can see from the same color there. We're flattening science, we're making it accessible, teams are the new normal. And I read a very interesting book. I'm not actually using the whole title. The actual title of the book is Why I Hate the Ivy League by Malcolm Gladwell. He talks about two different ways of doing things. The superstar-driven astronomy is very much like the traditional astronomy. It reminds us of an American basketball team where the superstar really matters. What about James Webb? Well, it's actually much more like a European football team, right? The quality of the team matters. The weakest link matters. And in fact, we saw this on James Webb when a technician decided to improvise to cut off some bolts with a hacksaw on our sunshade. It cost us 3 months, 3 years, a hearing at the House, almost got canceled, and we had to raise an extra $800 million to get James Webb launched because the weakest link didn't work. The quality of the team is the key on James Webb. It's a weak link phenomenon, and that's the way we do science today. So finally, what's the other lesson? I hadn't really appreciated this at first, but it's the importance of the idea. The super collider collapsed. The Large Hadron Collider succeeded. JWST succeeded. And we estimate over 20,000 people worked on JWST. And for some of these, this program consumed most of their professional career. Why? Well, I saw this. This is the phasing of the primary mirror in March of 2022. Everybody was standing around watching this. This was before the mirrors got phased, and then they got phased. And, we expect everybody to go, oh my God, look at that sharp image. No, everybody in the room, the engineers and the technicians, were looking at the background. They're asking, what are all those little dots? And we said, oh, those are galaxies. The entire engineering and technical team spent their entire time looking at galaxies in the background, not at the real aligned geode. They were just fascinated. As one of them said to me, so this thing really works. And I think that's the point here. So take this image here that Klaus talked about. What inspired it? This is what inspired the color choice of color palette. It wasn't just a chromatic technical scale. Joe Pasquale had actually seen the very many Monet paintings of Reims Cathedral and thought about how colors and choices should be made. But when he did this, he actually made some artistic choices that, as he said, outweighed by the aesthetic quality of the resulting image, which still conveys accurate science results. This was a passion that they put into this. They were driven by more than just making a color image. This was something they cared about. And if you walk around our industrial partners today, these are what you hear. When are you getting habitable worlds going? I do not want to move into the classified world. My European colleagues, that means the top secret world where you don't get to tell your wife or your husband or your family what you do. Another engineer from Northrop Grumman, can you please get the next observatory going? Right now, I have to work on Moonland. But we've been there, we've done that. And I think it's this story that we can tell ourselves. Over the last 500 years, we've gone from Galileo to these incredible James Webb results, deepest of the universe. We're seeing our first hints of what exoplanets are. And then there's the promise that maybe we can take a movie like this in the 2040s of another solar system like our own. The idea that in less than 500 years, we can. What can we? Well, the Copernican and Darwin revolution suggests that finding life elsewhere will bring about an irreversible change in our worldview. Ideas like this drive people to spend their careers working for astronomers, working on just the ideal of a telescope to actually explore. We should never undervalue how important these ideas are. And so I finished on a last quote, and I apologize. I don't come from the Catholic tradition, so this was the best quote I could come up with from Fleet Foxes. I was raised up believing I was somehow unique, like a snowflake, distinct among snowflakes, unique in every way you can see. Now, after some thinking, I'd rather be a functioning cog in a great machine serving something beyond me. That's what the James Webb has done for an enormous number of people. And that's how we solve complex problems going forward. That, I think, is the ultimate contribution of the James Webb. It shows us how to do these in this kind of incredible way.